this is 8.4. And we are once again talking about inference. So that means you are either going to reject or fail to reject a null hypothesis, right? We're going to make a hypothesis, a null hypothesis. We're going to have an alternative hypothesis, and then we're going to play king of the mountain. And we're going to see, does the null hypothesis remain king of the mountain, or does our alternative hypothesis reject the null, push it off, and become the new king of the mountain? That's the game that we're playing. That's the end game. This time, instead of working with means and standard deviations, we are working with proportions of success, and proportions of failure. We're now working with P's and Q's. And so we worked with P's and Q's back on 7.4 and 7.5. So we had a good introduction to P's and Q's in the previous chapter, but this time, instead of doing confidence intervals with P's and Q's, we're doing inference, hypothesis testing. Here is how you calculate P, or P hat as it's called. You take the number of successes and you divide it by the number of trials. It's sort of the same calculation we did with probability. And to calculate your z-score, when we were working with means and standard deviations, this is how you calculated the z-score. But we're not working with these anymore. We're now working with P's and Q's. And so this is how you calculate your z-score. Remember, the spreadsheet is going to calculate this z-score for you. So this is the mathematics behind the calculation, but you don't have to memorize it or worry about plugging numbers in, because the spreadsheet's going to do this calculation for you once you give it the value for P and P hat. P hat is from the sample and P is from the population. Or in other words, this is your alternative hypothesis and this is the null hypothesis, if you want to think about it that way. P sub 0 is the null hypothesis. P hat comes from your sample. And so this is what we're going to do. And then from here on out, the routine is basically what we've been doing for the past 3 sections. You are going to have a null hypothesis. This is the null. This is the reigning king of the mountain. And we are going to suggest an alternative hypothesis, what we think the actual values are. You're going to create, then these are normally distributed. So the null hypothesis is going to be right here. This is your null hypothesis, P sub 0. And then you're going to calculate an alternative hypothesis. And you're going to say that alternative is either less than P, greater than P, or not equal to P. So if it's less than, let's say this is your alternative hypothesis right here, and you want less than, then you are finding the area to the left of the tail. If your P alt maybe is over on this side and you're greater than, you're looking for the area above that tail. And if it's not equal to, then you take the area under one tail, multiply it by 2. Because it's symmetrical, you can just find one tail and multiply by 2. This is going to give you something called a P value, an area. Remember, your P value is an area, and you are going to compare that to a threshold, maybe let's say 5%. So if that area comes in below 5%, let's say 2% for the sake of argument, that's good for us. That means we get to reject the null hypothesis. We push the king off the mountain, and our alternative hypothesis takes its place. On the other hand, if this P value, if the area under the tail comes in above 5%, let's say 8%, then that's bad for us. We fail to reject the null. We foot faulted. We went over the threshold, and the king of the mountain remains. We fail to reject the null. This is the game that we're playing. So it all boils down to, how do you find the area under the curve, either above or below? So this is question number 4, and they are looking for a P value. So here we go. We're conducting a study to see if the accuracy rate of fingerprint identification is significantly different. Okay, significantly different means not equal to. And you see that symbolically right here, not equal to. It's not less than, it's not greater than. We're not sure which one it is. Maybe it's less than, maybe it's greater than, we're not quite sure. So we're just going to say it's different. So this is our null hypothesis, 52%. So for your null hypothesis, we can just put in 52 over 100. So in this problem, we're just going to take our z-score right here and put it in the formula norms dist. So I'm going to do that down below right here. So I'm going to say equals norms dist, and then I'm going to put in my z-score, negative 2.744. And there is the area under the tail of that z-score. Part of this is understanding what the spreadsheet does. The spreadsheets are not meant to be just a black box that you type in numbers into the yellow boxes, you get an answer and you're done. Part of the learning process is to understand what are the formulas, why are they there? So I'm going to take this value and I'm just going to multiply it by 2, and that will give me the area under 2 tails. So I'm going to copy that. I'll paste it here. I'm going to round it to 4 decimals, and we're going to get it right. Past studies have indicated that the percentage of smokers was estimated to be about 34%. So again, this is the population. The percentage of smokers was 34%. So we're going to put 34 over 100. That gives me my p-value of 0.34, q-value of that. Okay, great. Given the new smoking cessation programs have been implemented in a percent, blah, 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 you randomly survey 1,679 people. So that is my sample size, 1679. Of those, 517 smoked. So we're going to put in 517 divided by 1679, and we get a p-value of 30.79. Historically, it was 34%. Now it's about 31%. Is that significant at the 5% threshold? And if we surveyed another 1679 and another 1679 and another 1679, maybe we just happen to survey a batch with fewer smokers. That's why the rate is lower. And so that's part of this idea of a normal distribution, is saying if we were to go out and survey this many people again and again and again and again and again, how likely is it that we would get the same 517? And so you can't just go by the p-values. This one's 34, this one's 31. Well, of course it's lower. No, you can't say that because maybe you have a biased sample. So we're going to use 5% as our threshold. And so if we have a normal distribution, the null is at 34%. That is the null hypothesis. That is P of the null. We went and did a sample, and we collected information from our sample, and our sample came back at about 31%. It was 30.9. This is the proportion of success for our alternative. And we believe that the number of smokers has reduced. Reduced meaning is less than. So less than means we are looking for the area under this tail to the left of the tail. What is this p-value? And we are comparing this at a 5% threshold. So if this value comes in above 5%, that's bad for us. We fail to reject. If this value comes in below 5%, that's good for us. We reject the null, and the 31% becomes the new king of the mountain. The null hypothesis is that we're not using mu's, we're not using means, that the proportion of success is 34%. Our alternative is that the proportion is less than 34. Because it's reduced, this is a left-tailed situation. Less than, right? Been reduced, less than. Our significance value is 0.05. That's our threshold. The significance value is the 5%. And now we're going to calculate our test statistic. Negative 2.77. There it is. And we got to round this, to 2 decimals. So there's our test statistic, negative 2.77. And our p-value, we're looking for the area below the target. Here is our p-value. Copy paste. And we need to round that to what? 4 decimal places. So that is our area, 0.0028. So again, going back to this, our area came in at 0.0028, which is way below 5%. So this is good. That means we get to reject the null hypothesis. That means 34, you're out. And the new value is 31. We reject the null since the p-value is less than the significance. Yeah, that sounds right. That's what we want. We reject the null because the p-value is not less than. No, you would not reject if it was not less than. We fail to reject. Now we reject it. We fail to reject. Nah, we reject it. So the very first one is the correct assumption. The sample data supports the claim that the percentage of smokers is less than 34%. Looks good to me, I think. Let's try it. Let's see how we do. Uh-oh, something is wrong. My assumptions are all right. Everything else is right. What did I do wrong here? It's got to be a decimal. 0.34. 0.34. Should I feel bad about making that mistake? Absolutely not. Absolutely not. And you shouldn't feel bad about making a mistake like that too. We understood what was going on. It was easy to correct. This is one of those mental things where you're like, oh, it's 34%. I'll just put a 34 in there. And you forget to change it into a decimal. Once we convert it to a decimal, everything's good to go.